Hi all. So what I brought you all here today to talk about something that I've foreseen coming to us with the advent of 62443 and signed firmware. And as we move ahead for cybersecurity in industrial applications, I realized that there was a lot of parity between that and E-enabled aircraft. And this even far precedes E-enabled aircraft. So I wanted to apply those lessons here and maybe take us on a different kind of journey for once. So disclaimer, these are opinions of my own. The observations I've made do not represent those of my employer, partners, nor past, present, future clients and engagements. Please be responsible with this information. Much of it is available on the dark web through various forums and people that have not properly controlled classified documents or controlled documents. So I'm going to start with a quote of a certain gentleman we should all know by name. He was also a past S4 attendee, a keynote speaker, a Mr. Whitfield Diffie. Lots of people are working in cryptography and have no deep concern with real application issues. They're trying to discover clever things to write papers about. And we often see this show horsing left, right, and center. So I'm going to introduce the concept of PKI and E-enabled aircraft. And we look at the complexity of an aircraft and all the supporting infrastructure. We basically forget that they're a big, giant flying OT site. And they're also surrounded by other OT infrastructure. There's systems of systems. There's many integrators in them. We might see one particular OEM that manufactures the aircraft, but the reality is they're actually not really being manufactured. They're being integrated, even though it happens in inside of one facility. And we think that every aircraft is almost the same, and that's true for the most part. That it's relatively homogeneous in comparison to a refinery or a pipeline or all of the infrastructure you have at different sites that do different things. And you might hear me use the word aircraft or airframe or tail. Those words are all synonymous. And every single plane, even when they roll off the line, is different from one another. And at any given time, every aircraft is also different for each other based on various things. Even if you had the same software loads, same hardware in them, although that's not true. And they also generate different characteristics. So one might actually generate a magnitude of 10 times more logs than another plane, even with the same pilots and the same routes. There's numerous software parts to be loaded on an aircraft, and I'll generally call them software parts for now. They need to be signed, loaded, and managed on an aircraft. But how do you deal with things like a certificate match? How do you deal with things where if I have a plane that needs to take off in the next 2 hours, and I have another one that just landed, and it's there for 8, well, I can swap out a part from one aircraft to another, despite different cryptography differences. What happens when someone misses a step in a statement of procedure, an SOP? So I will get a whole bunch of errors. So should I ground the plane? Should that plane not take off? Maybe, maybe not. What about maintenance scheduling? We're all familiar with it, but on an aircraft it's far more critical than you and I would like to believe. And it's very, very complex. Now the aviation ecosystem, this is a kind of a 65,000-foot view, and it's oversimplified. You have so many systems aboard the aircraft, and you might refer them as different names like an ONS, electronic flight bag, central management system. You have all of the different networking. So there's stuff over traditional analog networks. There's stuff over SAT. There's local comms, especially if you're dealing with alternates and low visibility airports. You have flight operations data. So you have stuff that's coming off of the electronic flight black boxes, so an FDR. You have nav data, which is actually another form of a configurable part, which you and I typically don't consider. You have the surveillance systems. You have the manifests, you have the gate info, routing, and then there's all of the stuff that supports that aircraft. That's your aircraft maintenance systems, your UMDs, universal maintenance devices. You have things such as the E-enabled ground systems, which store all of these parts or all the information for each aircraft, including its health. And then you have third-party components. And there's a lot of news on this, and we think maybe one vendor is responsible for the integration of that aircraft. But the reality is that there's all these extra things that you can either buy the plane with different trim, just like you would go to a car dealership and buy a Ford Focus, for example. Well, aircraft are also the same way. A carrier has the opportunity to change that aircraft very drastically different than the characteristics that when it left said manufacturer. So there's all of these other things that we need to consider. And then kind of going back to something we're more familiar with, which would be like the OT systems in an airport. Airlines are probably the most integrated organization on this planet that you and I take for granted. The moment that you check into an airport and your bag goes on that conveyor belt, you're at the will of an OT system. The aircraft is an OT system, the airport's an OT system, and it's all convergent. If that suitcase goes aboard the plane and you are not aboard at a time, that suitcase needs to be removed from that aircraft before it can fly. So you have something that is very trivial and maybe IT or enterprise focused in nature at the end user level, and it has a direct impact on an OT process without affecting safety, reliability, and productivity. You also have things like GPS, ground fencing, and then all of that OT infrastructure. Many airports are directly connected to pipelines to do custody transfers. And I'll circle back on that later, but there's all this extra stuff, including maintenance, weight DCSs, distributed systems for that. You have all of the storage for fuel. You name it, it's probably there, and we all take it for granted. So what this is really about is PKI, and it hinges on this thing called a Loadable Software aircraft part. And this is a bit of an Aviation 101 for newer aircraft, although it does apply to things like the old Dash 8s. So what is a Loadable Software aircraft part? Or you'll see me use the term LSAP. It's anything software or configuration related to be loaded aboard an aircraft. Now that's not things like physical units, such as the equivalent of a PLC on an aircraft or a line unit. But this is also true for E-enabled aircraft or non-E-enabled aircraft. So that could be something like a Airbus 318. They're still using electronic parts and it have a different, maybe a format. But there's four main pieces that we use here when you're managing E-enabled aircraft. It's for the tracking, the asset management for the aircraft, supply chain and vendor authenticity. So did that part come from said vendor? Centralized parts and management. And there's a key term here that we don't realize. It's called synchronization of fleet management. So the idea is that any pilot can jump into another aircraft for that carrier, and it should behave more or less the same as another aircraft. So that is synchronization of assets. We also see this in control rooms. If I have an operator that jumps on system A, it should be the same on system B when he or she comes on their next shift. So that is synchronization of fleet management. Then there's aircraft integrity and compliance. At that time in flight, I knew that that piece of software was loaded. And so we were operating those things for forensics purposes, for things like FFA analysis, and also just as part of due diligence. So we're familiar with this concept, the case for signed firmware in OT, and we're starting to see it more and more. Maybe we should have thought about this 10, 15 years ago, which we heard about it before. It's just taken a long time. Now this is an oversimplified version for an IT enterprise software. Multiple developers or systems integrators adding their products to a larger product itself. And that needs to be some sort of third-party code validation there. That could be something as simple as a git signing of a commit. Then you have your building and packaging. So if you have something like Install Shield and you're wrapping up a binary for installation on a Windows box, you have the infrastructure to sign said binary to say, I'm ABC Corp, and this is the software invalid between that time. It's also to be used there to verify the authenticity and integrity of modules if you're working with different partners. Now, this is where things start to get weird, and this is an issue in the IT world, it's the OT world, and it's also an issue for aircraft operators or carriers. You have portal downloads. How do I know that that stuff came from the portal? Well, when we're dealing with things like refineries, it's about 10 vendors, 15, 20 different products, various eras, and so on and so on. But how many of us have really thought about where do our integrators get their software? Generally speaking, they're going to get the first thing that shows up on Google, especially for legacy products, or off of some file share that happens to be on some legacy operator's equipment. And it swaps multiple hands. Then we have our asset owner, who also maybe is storing it on a file share and not managing any aspects of this. And considering transport and arrest, and also documentation. So there's this big case for signed firmware. This is the part you're probably going to love to hear. This is how it works for aircraft. This is a software part. And they use this term called a crate, which I think we should use as the default vocabulary in our industry, because it makes sense. I get a PLC, it comes in a box. I get a pump, it comes in a crate or on a pallet. So the A-Rank 827 standard, which is a relatively easily accessible standard, works in this concept. How many of you have used Secure U-Boot? I hope more hands go up, please. It works on the same premise. It has a wrapper around a binary or a piece of component. It tells you what it is, who signed it, so on. But in a crate, it shows up with a manifest saying, this is that part. When you get your stuff from Amazon, it comes with a little thing saying, this is how many pieces were in there and what they were with all of the SKUs. A crate has the supporting documents. For example, if there's a chain of custody, there might be some supporting references and manuals. There'll be the signatures. And inside of that little container, there's another subcontainer. And this is where the LSAP comes back. And that would be the ARINC 665. Inside of there, you'll have your media set of batch operations. So that might be a script of some sort. And field loadable software, an FLS. Before some of the later E-enabled software, they typically just dealt with FLSs. Now, what's really crazy is how many of you know that most aircraft still use floppies? USB sticks, CDs, DVDs, data loaders. Well, all those things are wrapped up inside this other box. Now, the process here to the right of that, this is how you validate an LSAP. Basically, you have all of those cryptographic primitives, including the signatures, the signing, and you move to the point where you both validate the certificate and whence it came, and also the authenticity of the part. So is it actually matching that certificate and onwards? This is a very critical step that I think we should map out a little better with standards like 62443 and its variations. This should be the way it's done across all vendors. There should be no differences in implementation, and that implementation should be both standardized and validated with as many sets of eyes. Because if we had done so, we wouldn't have the Windows Crypto API issues that we're dealing with today. So generally speaking, here's the issues with PKI overall, and we haven't even really gotten to the issues with OT. The overall, basically the total cost of ownership to manage infrastructure that is around PKI has a lot of weight. How many of you have an OT customer that actually has functional PKI on the operations side? There's maybe one hand. I know about maybe 3 or 4 firms, and I can count them on my fingers. The infrastructure supporting it. You need, if you're not doing it locally, it needs to be stored. Third-party interactions. How is those operability going to be? If I have an outsourcer, I have a distributed PKI, how will that work? Now, on an aircraft, it's very different because the carrier controls most of those aspects. But when you have refining or we have remote sites, it is not us that is maintaining that. Or even the vendor itself has their own PKI tree and is issuing things to that piece. Deployment complexity changes. I'll circle back on how that works for aircraft, but it's very different than how we would expect it to be. You have continual maintenance. We've never thought about that, but how do we manage the expiry of certificates on PLCs? Do we reboot it? Do we wait for another scheduled beast? Don't know. The procedure and enforcement, our technicians may have extra steps that we need to adjust for them. They might not have been cyber aware in the first place or even trained to do so. Their job might have been literally to do a lockout, remove the device, put the new device onto the DIN rail, connect the wires, and go. That's all they might have to do, or plug in some sort of firmware to load. There's a lack of automation with PKI. There's so many steps in that chain. What about MFA when you're doing a signing request? You have 2 operators, 2 different sets of mobile devices, and you're working through your trusted enrollment agent. And logging in SEMS, how will you deal with that? So generally speaking, it's supposed to help us with these kind of threats or risks. We have your OEM supplier compromise, third-party compromises, vendor portal spoofing, man in the middle. So let's say, for example, I own one of those maintenance laptops, and I can do hacks on that device, and typically those devices are not connected to any network, shape, or form for extended periods of time. How many of us have been in an airport where they wheel out what I call a crash cart with all those laptops to go deal with reservations when the system breaks? We should all be very familiar with this. It's my favorite time of the month. GPS and time compromise. You know, we've all known GPS and GNSS are very vulnerable. What happens when I change the time so far in the future and people actually take that and take it to the next level and invalidate all of our certificates? Our VPNs go down. We cannot connect things with web servers. We cannot do signing because the system says it's out of sync for clocks. Insider threats. I have a software that I can push logic on. It has access to the keys. I sign the firmware. It's all legitimate as far as I'm concerned. So there's no protection there. And the implementation itself is also a risk if poorly engineered, and I'll talk about that a bit more. Here's how it works for one particular type of aircraft manufacturer, but it pretty much applies across the board. You have this very important piece called the software part management. And then you have your third-party systems. That might be your PKI, your OEMs. They're third parties if you buy, for example, an extra heads-up display or the in-flight wireless. You have your PKI certificate management. That's your trusted enrollment systems. You might have ancillary systems. That'll be your Active Directory, file shares. It could be password managers. You name it, it's there. But the most important parts here is in that kind of a greeny-brown box. That you have your crating tool, your CSCT. your LSAPL, which is your library of loadable software parts. Between those two main systems, this is where you need to reflect a lot of things. If I want to do something very nefarious, those are the ones I'm going to go after besides the universal maintenance devices, or UMDs. When you receive an aircraft, you have 30 days to re-sign every part, change the certificates from the OEM upon delivery once you get it as an airline. That's a lot of work. But basically, you're out of date before you even started. All the parts that you receive from that vendor, you need to re-sign and store, not just load them. You have extra steps, like what happens where an SOP is missed. So I've seen this in many cases where an aircraft technician has missed a step and not updated basically the inventory list above that plane. That plane generated in excess of 100,000 logs for every hour, or entries in logs, for every hour of operation. So all of a sudden, your data processing, when it managed to get weight on wheels in a particular airport or country, is going to get very, very expensive in a hurry, and it's going to be very bursty. The latest parts might not even be on that aircraft anyways, because they're handled differently, or there's different scheduling. Parts might be missed or need to be introduced to the catalogs. And you've also generated for yourself two really big crown jewels that you didn't have before, besides just your PKI. The crating tool, the thing that can make valid parts, just like a builder in the software process, and that library of things that is basically what is good and bad and on which aircraft is on. But in OT critical infrastructure, this gets completely different and turned on its head. So imagine this particular scenario. How old are most facilities? How many of those refineries are beyond decades old, but 30, 40 years old, for the most part? And asset owners have a non-homogeneous environment. They might have a pipeline that goes to it. They might have a tank farm. They might have generators that do power generation, full of vendors, third parties, and tools. And the ICS ecosystem is largely very similar, and some of the names even overlap, but they're different business units. But PKI will add work. It should work, though. It addresses a specific set of issues that are slightly different than on an aircraft, which is not particularly for fleet synchronization. But the air handling needs to be very graceful. An aircraft, they don't really care that much that there's a certificate mismatch, even though the IT security team freaks out when they see the entries. It's more about how do we deal with things very different. My certificate expires, and you are maybe using a certain set of keys, asymmetric keys, for the new versions of Secure SIP. How do you replace that without causing a new connection? Will it just fail shut? What do you do? So in between the two worlds, here's where the change is for the most part, and I've overlapped aviation with OT generally. The main difference comes between the concept of fleet synchronization and site and integrity management. I can tell you at a given time where those certificates are, on what devices, what firmware is there, who did it, and also to the configurable items. There's the certification of devices. So in an aircraft, you have this concept of airworthiness, which is very different than we have for PLCs, although we do have other standards around ISA and including safety instrumentation levels. And we're trying to do attack prevention, which is very different than an aircraft, because that's not what they care about at all. Now, recently, the doors have kind of opened on the aviation world with a certain airline or a certain aircraft for various reasons, but their whole premise is built very differently, and so it's going to be interesting how things converge. So here's Vancouver Airport and all of the things around it. We didn't really realize this. Vancouver Airport, or YVR, burns 8 to 10 million Canadian gallons a day, which is 36 to 45,000 liters of jet fuel a day. It's so much fuel that the refinery in Vancouver, which is a relatively small refinery in Burnaby, is less than 80,000 barrels, and only 40% of the output product is jet fuel. Then you have these very large terminals that are going in with barges. That's only 1 to 2 extra days of fuel for that airport, should something go awry. You have the airport systems and the pipelines that even go through the cities. But when you look at how we're going to handle the certificates and parts, you can see how crazy this picture gets. All of these different players doing very different functions, very different systems, and some of them may interact, some may not, and some might make no sense and never be upgraded for many, many years. So this goes between all of the GPS and satellite links. You have things like wireless flow meters. You have things within the control center for let's for example, the air traffic management. Custody transfers, flow meter, you name it, it's all there, and we're going to have to manage that. What happens with distributed PKI? How do we deal with things like safety versus ops or ops security? How do we deal with a third party which gets compromised or has their PKI compromised? And then how do we deal with things like mismatches for cryptography primitives? So here's the so what, right? We all think PKI is great. I'm sure you've heard it. NIST has told you should use it. ISA has told you to use it. So the so what? Here's the bad issues. Manufacturing and delivery challenges for PLCs is going to get way harder when you want to onboard something either brand new or out of stock. You're going to have to change it up. Crypto air handling, how will we deal with that in a way that is both beneficial, effective, and safe in our industries? How would we deal with things like time, GPS, and GNSS dependencies? We still haven't figured that out. Most places, most receivers, particularly for NTP, with GPS used as a time source, they blindly accept whatever's being broadcasted unless you have the appropriate measures around them. The more complicated the receiver, the easier it is to break. Vendor lock-in may increase with cryptography because certain asset management solutions might only support those devices with that sort of PKI API. Things might get very different. As an asset owner, this would be the last thing that I want. This would be my biggest gripe when I'm doing an RFQ or an RFP. It will be there in my contracts. PKI now and all this supporting infrastructure is now another target that I need to protect. Just like my historians, just like my HMIs, just like everything else, it becomes in that same group. It might even be more important in some regards. Maintenance of said certificates and cryptographic primitives. Expiry, revocation, apps. I can't just remove a certificate and forget about it. You have all of the manual processes around, which is your SOPs, your signing, your deploying of firmware, and all that logic. That's the bad part about PKI. It just makes life harder. So hopefully you can automate. Now here's the good thing here. The potential benefits and advantages should, long-term wise, outweigh any of the negatives I've just talked about. So it's not all doom and gloom. Asset reality synchronization. Your assets really have to manage what you have in inventory, otherwise things won't work. You need to have those things basically in order and stored properly. Code integrity changes. I can now prove that that code is exactly as was intended when it was shipped or by said producer or builder. You can do origins tracing now. I can tell you from which box at what time that certificate was used to sign a particular binary. Third-party access management. I can look like Gandalf on a bridge, putting down my staff and saying, "Thou shalt not pass." I can instantly revoke access to things very differently because the system will know within a certain amount of time. Artifact controls, minus my great super Canadian spelling with an extra E. Latest versions of artifacts can be tracked. We see this on the application side for DevOps. We have our file nexuses. This is just one piece that we get for free. Forced vendor convergence, which I would love to see. I do not want to see silos at my sites. I do not want to see it with my vendors. And it's an opportunity for automation and to make the lives of those that are working with those systems, whether that's programming, whether that's being an operator doing alarm management, it's an area there we can deal with all those things very simplistically and driven through technology. So my main last slide here is the roadmap of where we are today. Right now, we're at the first point where industrial OEMs continue to develop secure products or platforms. Sorry, have I seen any in the real world yet? No. But that's basing around 62443 to provide secure firmware. Now, some vendors have their own mix match or proprietary solutions, or they're piggybacking on things like Secure Boot. But we're not there yet. NIST hasn't even told us how to do it properly. So how will we deal with it? So we need open standards for safe, interoperable solutions and event handling on how we will deal with things like certificate mismatches. We need to figure out how to bring down the cost of things like hardware crypto birth certificates for devices. How many customers actually really want to pay an extra fee to find out that they have a truly unique device? I don't really know that many of them. Some may do, depending on the application. For the most part, most customers do not care. They just want the lowest cost device because they bought 10,000 of them. Third-party risk with PKI needs to be addressed. We still haven't figured out how to manage third-party risk properly because they're in there installing LTE modems and bypassing all of our controls. So there's another piece we're going to have to deal with PKI there. And our automation and APIs need to be mandatory as part of the solution as we move forward for secure firmware. On the side of aircraft, they've done some work, but there's a very manual process. 2 individuals need to go do a CSR. New parts come in, engineers onboard them into the software library system. Then they are created under another SOP, and then they finally maybe will get scheduled for deployment aboard of an aircraft in some point in the future. And then those parts will then be loaded on the plane. Is there validation? That's maybe a step we should check a little farther. So there's more work there we need to do. But from the moment, whatever it is that puts that software in there, it should validate by de facto what is going onto the device and whence it came and whether or not it actually was successfully loaded. We also need to fix GPS and timing issues before we can really move forward on this. Now, it's not immediately an issue. There's other ways to deal with time synchronization, physical iridium clocks, multiple sources of time, different time sources, or telling your systems to not manage it. There's an interesting aspect there. If you manage to play with Active Directory, there's a limit with Windows by default how much time jump you can deal with. Well, if I have access to the registry tree, I can push out through Active Directory and allow those clocks to jump way out into the future. So we need to deal with some of that time, at least elegantly. And this isn't just for crypto. And the end result, whatever we have and we go to deploy, needs to be sane. So if it's not sane, it won't be adopted, or very, very slow unless it's forced through something like a NERC-CIP legislation. It needs to be adopted by everybody, and it can't be to see who has the biggest stick in the room because they have PKI for a feature checkbox. It has to be done in a way that we all agree on, and it might take decades to do properly. But we need to do this right to make secure firmware and logic a success. For example, if you're a carrier, and let's say you had 20 aircraft, it's already a humongous challenge to make sure that those aircraft are running and signing everything that you are dealing with. The algorithms change. That might not mean it's insecure, but at least certain things or aspects are changing and moving. The lifetime of an aircraft is similar to an OT facility. 20 years is not unheard of for many aircraft. How old are most of the Dash 8s? They're probably the original ones that weren't remanufactured after another airline did an acquisition of them. So we need to manage that properly. Because if it's not managed properly, not implemented securely, we'll wind up with things like OpenSSL and all of the wonderful things that it keeps and continues to give us. So I hope you enjoyed my talk. My Twitter handle and LinkedIn are there, my email as well. And feel free to reach out if you want more in-depth questions and answers.
Thank you so much. Any questions now? Oh, we have one here.
Great talk. So, great talk. Thank you. A lot of just not a vendor plug because I don't work for the company, but there's a company out there that actually does a lot of automation for PKI. All the things that you mentioned, the challenges, they kind of handle that automated. Revocation, rechecking, redeployment, kind of all the things called Vanify. I don't know if you guys kind of want to look at it, but it really solves a lot of things that you brought up as a challenge.
Yeah, it might. There's a couple services that do most of that stuff for airlines without giving away who and what and who they're tied to. They do that. Now, but the issue still is, I have air gaps, which is Joe Blow or Jane Doe, the technician, that is pushing that software to the aircraft. Today, the aircraft is not attached to any network at the gate, and it shouldn't be. So automation only gets us so far. There's still human aspects that we need to deal with. We also need to think, most of the time, most of these things do not have internet connectivity and are very strictly controlled. So you'd have to do a balance of solutions, whether it's a hybrid solution on-prem or even, I believe, what's called now the fog, which would be a localized cloud. So you'd have to manage things a bit differently in order to automate. But there is solutions to do so, I agree. But it will be interesting on how we can tie everyone together without making the wheel round everywhere.
All right. Thank you so much, Ron.
Thank you.